Welcome back. We've talked about the high-level math of AI, but now it's time to zoom all the way in. We're going to look at the math inside the single, fundamental building block of every neural network, the artificial neuron. So what is a neuron, mathematically? It's just a very simple function. It's a tiny computational unit that takes in some numbers as input, does a few quick calculations, and spits out a single number as output. The best analogy is to think of a single neuron as a tiny voter. It's designed to make one simple yes or no decision based on the evidence it receives. The process begins with the inputs. Each input value that flows into the neuron is multiplied by a weight. A weight is just a number that represents how important that connection is. A large weight means this input is very influential. A small weight means it's less important. The neuron then calculates the weighted sum by adding all these results together. The next step is to add the bias. The bias is another number, but it's internal to the neuron and not connected to any input. Its job is to act as an offset, making it easier or harder for the neuron to fire. In our voter analogy, the weighted sum represents the evidence from advisors, while the bias represents the voter's own personal, pre-existing inclination to vote one way or the other. The final step is the activation function. The result of the weighted sum plus the bias is passed through one last function. This activation function does two crucial things. It introduces nonlinearity, which is essential for learning complex patterns, and it squashes the output into a standardized range, like 0 to 1. This is the final trigger that determines the neuron's output signal. So, let's review the entire process. For every neuron, data flows through this three-step process. 1. Calculate the weighted sum of the inputs. 2. Add the bias. And 3. Pass the result through an activation function. The number that comes out is the neuron's final output, which is then passed on as an input to other neurons in the next layer. And that's the secret. You now understand the simple math that happens inside every neuron. A massive, complex neural network is really just built from thousands of these simple Lego bricks, all working together. In our next lesson, we will focus specifically on that crucial final step, as we explore the most common and important activation functions used in AI.